Welcome to Chip Studio, and in previous video I have studied event regions. So in this video we will study about blocking and non-blocking assignments. So as you know, these regions are of our Verilog, and we only need Verilog these regions for understanding of our blocking and non-blocking assignment. So let's revise. Like in active region, your blocking assignment RHS and LHS both will execute in your active region of our blocking assignment, as I have written here, and only RHS of our non-blocking assignment, only RHS of our non-blocking assignment will execute in our active region, and our non-blocking region, our LHS will update of our non-blocking assignment. Okay, so fully execution of NBA or non-blocking assignment is executed in our NB region, full execution, and dollar display will execute here in our active region, and dollar monitor will execute here, as you can see here, dollars. So these are the things we need for our blocking and non-blocking assignment. So this is your first difference. You can say execution are different, and you can mention your execution statements whichever executed at what time. So let's give a short introduction. Is that blocking execute immediately? Yeah, immediately at active region, both LHS and RHS, and non-blocking update schedule at end of time step, because these are having different region for LHS and RHS, so update scheduled. And this is the common question in your interview, and you can say for freshers this is the first question. If you have written any D-flop code, any code we have using this blocking and non-blocking assignment, so you should know that. Now your blocking assignment. So second difference is that, for example, A equal to 1, then B will wait for A, then B will execute, and it will get the value of A equal to 1, and then C will wait for B, and B will get the value of A, and C will get the value of B. So this is your sequential. This is your sequential assignment, or compiler will take it sequentially, like A will execute, B will execute, and C will execute. Because of that, A will get 1, B will get 1, C will get 1. So both of all the three variables you can have a value 1, and therefore the result of the execution will be 1 1 1. Okay, one another thing to mention, like for the synthesis purpose, that A is your one combinational block C1, you can say A will execute this one, then one sequential block B is there, so it will execute here like C2 combinational block, and C is our third sequential combinational block. So this three combinational block, because there is a combinational execution, you can say equal to one assignment only, simple assignment. So after all execution of this this combinational block, one combinational block will form in synthesis, and after that it will go to your flop to store the value. So this type of circuit be visible in synthesis. First is your combination block, and second is your flop. So you should remember this. This is your second difference, that it has one flop or one storage block is created in synthesis of blocking assignment. Second thing is our non-blocking assignment. So second difference is that A of non-blocking of 1 will execute. Similar to that, B will execute at its own pace, and C will execute on its own pace. Means it will not depend on your value of A, and C will not depend on value of B. So execution are happening similar to parallel but not parallel, because execution are at different event regions, so it will seem like it is a parallel, but it's not parallel. So what's the difference? Difference is that in dollar display it execute in our active region, and because it is the first value, but B will not get value because A is executing parallelly and B is executing parallel in different event region. So B will get its default value like X, because for example all the variables are reg here. Okay, so for example all the variables are reg, so its default value is X, and C will also get X. And for example if it is int, then we will get 0 0, or bit we will get 0 0. So I have taken reg, X. If I have taken int, it will get 0 0. So the values are not getting our dollar display, because dollar display will execute in active region. But what if we want the value? Because we want something to get the value of A, B, C now. So you will see these values in dollar monitor or dollar strobe, because its region is after NB region. So after NB region we will get all the values of our ABC in our monitor or dollar strobe. For example, if you are using dollar strobe we are using, so we will get A equal to 1, B equal to 1, and C equal to 1. All the final values of our assignments. Now, as previously I have said that this is your combinational block 1, combinational block 2, and combinational block 3. So C1, for example, combinational block 1 will execute, then it will store these values in one flop. Then C2 will have another combinational block. It is for visualization. Third, this is one, it is also flop, and it is also flop. Then C3 will have our another combinational block, and another storage element will be created like flop. So there is 3 combination block and have 3 your storage block in non-blocking assignment in synthesis. So this is difference in their synthesis of circuit. So you should remember the synthesis is also different if you are using different system, and these non-blocking are mostly used for sequential circuits, you can say flops, latches, and everything, because it stores values for your previous value. And blocking assignment is used for your combinational circuit. Now use cases, blocking combination circuit, I have already explained that, and sequential logic. Last important thing is that we cannot mix these two statements. In real world scenarios, if Verilog or design engineer using Verilog, he will only design if it is blocking, then blocking only, if it is non-blocking, then non-blocking only on whole file. So this but in interview they will ask like first statement is blocking, another statement is non-blocking. So they will ask this simultaneously for your understanding of the basic concepts. Tips for debugging: never mix blocking non-blocking assignment, as I said earlier, because it is confusing and compiler will get confused and you will get your race around condition and everything. For same signal inside a signal, yes, always block. If you use same signal, then it will get confused. This prevents simulation mismatch and timing bugs. Timing bugs or race around condition, everything depends on your blocking non assignment proper use. So keep that in mind. So thank you for your time, and if you want a video for inter and inter relay, you can comment me and I will make that video. And it is also depend on your blocking, non-blocking, and event results. Somewhat a different concept, but for interview perspective. So thank you.
All I got is working, never stop searching, never quite so thirsty. I'm toxic.